4, the parametric equations of a curve are x equals to ln cos theta and y equals to 3 theta minus tan theta. In part 1, we have to express dy dx in terms of tan theta. So to find dy dx, first we'll find dx by d theta. Now, as it is ln of cos theta, so when we're differentiating a ln function, we write the function which is with ln in the denominator and its derivative in the numerator. So the derivative of cos theta is minus sine theta. So dx by d theta will become minus sine theta upon cos theta. And now finding dy by d theta. So differentiating 3 theta, that will become 3. And when we differentiate tan theta, that will become sec square theta. So this will become 3 minus sec square theta. Now to find dy by dx, we will divide dy d theta by dx d theta. So we'll get dy dx is equals to 3 minus sec square theta upon minus sine theta upon cos theta. Now, as we have to express this in terms of tan theta, we know that sine upon cos is tan. So dy by dx can now be written as 3 minus sec square theta divided by minus tan theta. And now we can write an identity in place of a sec square theta. So we know that 1 plus tan square is equals to sec squared. So this will become dy by dx is equals to 3 minus, and this will become 1 plus tan squared theta divided by minus tan theta. Simplifying, we'll get 3 minus 1, which is equals to 2. So that will become 2 minus tan squared theta divided by minus tan theta. Now, as we have a negative in the denominator, so we can just multiply by minus in the numerator and the denominator. So the final answer will become tan squared theta minus 2 divided by tan theta. In part 2, we have to find the exact y-coordinate of the point on the curve at which the gradient of the normal is equal to 1. Now, we know that dy by dx in the first part was given as, so dy by dx is equals to tan square minus 2 divided by tan theta. Now, as the dy dx represents the gradient of the tangent, so, and the gradient of the normal is equals to 1, so we can replace dy by dx by minus 1, as the gradient of the normal is a negative reciprocal. So this will become minus 1 is equals to tan square minus 2 upon tan theta. Cross multiplying, we'll get minus tan is equals to tan squared minus 2. Bringing the tan on the right hand side, we get tan squared plus tan minus 2 equals to 0. Now applying middle term breaking, we'll get tan squared plus 2 tan minus 2 equals to 0. This will become tan into tan plus 2 minus 1 into tan, and this will become, so we'll take 1 common over here, and this will become 1 into tan plus 2 equals to 0. So we'll get tan minus 1 and tan plus 2 is equals to 0. So this will become tan theta equals to 1 and tan theta will be is equals to minus 2. Now substituting these values in the calculator, so tan inverse of 1, that will become theta equals to pi upon 4. And taking tan inverse of minus 2, we'll get theta that will be equals to 3 pi upon 4 minus 1. Now, as the limits for the value of theta is from 0 to 1 upon 2 pi, we'll only have these two values of theta as a final answer.